Alright, I'm going to do a quick one here for you today. I'm hidden behind the microphone. Hello everybody. Good to see you. How you doing? Having a good day? Having a good Easter weekend? I really enjoyed yesterday's project, by the way. So one of those really rewarding projects. One that I really enjoyed immensely for a long time. So maybe I can move this a little bit like that and you can still hear me. So I've got an optical shaft encoder over here, okay? It is incremental and the line count is 1024. So how it works is you can work this off 5 to 30 volts. What they do is they regulate it internally. So what comes out is TTL. It's 5 volts, okay? So it's a 5 to 30 volt encoder, but the output is TTL. So it's 5 volts coming out. So over there, I've got the scope cam, and you can see the voltages coming out. Now let's talk about quadrature, so let's just get smooth rotation going. Okay. So as you can see over here, we got A and we got B, alright? And now 90 degrees out of phase, alright? So A is leading B when I turn it clockwise, and they're differential signals, okay? They're RS485 signals. That means that when A switches high, A naught switches low, okay? And then in the opposite state, A is low and B is high, like that, okay? And the same with the B channel, sorry, A and A naught. Then you got A. So that's high and that's low. And the same here on B and B naught. There you got B and B naught. Sorry, B naught and B. Okay. So they change state. Now over here, I could actually move this closer, then you guys should be able to see what I'm doing with the LEDs. Right, so I've connected LEDs to the output, so one is in one direction, one in the other direction. So as I change it, so let's roll the scope again. So as I change it, you can see channel A changing there on the scope, and you can see change of polarity. So that's channel A, that's channel B. So you can see them changing polarity. So we now turn it the other way, this pattern changes. Because when I turn it clockwise, you can see A is leading over here. When I go counterclockwise, B is leading. So that's how the controller knows the direction. Alright? It's because of which one is leading. There you got A leading again, going high first, and there you got B leading counterclockwise, like so. So those are the 4 wires that come out of an incremental encoder with RS485 differential signals, alright? An HTL encoder will only have an A and a B, it won't have a complement. the A naught and the B naught is called a complement. Alright? So if you don't have a scope, you can just use LEDs on the output, in this case with some 330 ohm resistors, to see whether your encoder is working. Alright? Like that. Now voltage wise, if I were to, okay, now turn them off. Okay, so A, so then over there, if we were to measure, we want vertical, and we want, suppose Vmax will do. Yeah, there we go, 4.7 volts. Alright. So that's it like that. So if I turn on that one and we measure on channel 2, take it away. Alright, so when channel 1 is low, it's a 0 volt, it's not a negative voltage, alright? Channel 2, or A naught, is high at 4.9 volts. So let's just look at that, it's captured that. So you can see that both of them switch up to about 4.7, 4.8 volts over there. They don't go negative. What they are doing is changing. So if I select this one, let's overlay them. Let's move that one down. Move that one down. So now you can clearly see where the one switches low, the other one switches high. Alright. So we're going to roll the scope again. Go a little faster. Doesn't matter. There you can see it nicely. A goes low and A naught goes high. So that's your differential signal changing state. Then you can see it over here on the LEDs. So when one output goes low, the other one goes high. And I've got the LEDs connected back to back. Right. So this wire crosses over. So from that cathode, I'm going to that anode. And from that cathode, I'm going to that anode. And then this is one channel. That's my other channel over there. And there's the crossover wires where I've connected the LEDs back to back across the channel. Okay? So you can see the polarity changing. And that's how an RS485 signal works. Alright? So what you're wanting to do is with your scope I would have to move them back down again, so I'll move that one over there, move that one over there, so it looks like that. No, but you messed that up a bit. Now let's move that one up. to there. There we go, there. More or less back where they used to be. Yeah, now you can see it again. That's counterclockwise, clockwise. So clockwise, A at the bottom is leading. Counterclockwise, B at the top is leading. Actually, I've got it the wrong way around now. So it's clockwise, that's counterclockwise. That's how quadrature works. Okay. Now, I've got two taped up wires over here. That is called a marker. Okay, that is 1 pulse per revolution, and that is 1 pulse at the 0 degree mark. It's also a differential signal. Okay, so that indicates 0 degrees on the encoder. Okay, because this is not an absolute encoder, you have no way of knowing where that shaft is without doing a full revolution and finding 0 degrees. Okay, if it were an absolute encoder, you'd be reading data out and you'd be reading an actual position. Okay, and those can be single or multi-turn. Alright, so there you have it. This is incremental, gives you counts from which you can work out what speed is and what direction is, and that's what motion controllers and variable speed drives use for feedback, either speed or speed and position for distance and number of revolutions and stuff like that. Okay, got it. Okay, I think we've talked enough about this encoder. The reason I have it here is because it's scrapped. Somebody has stolen the clamping ring that goes around here, because there's a ring that compresses this around the shaft. These are slotted, this being a hollow shaft encoder. So the shaft fits in here like this, there's 10 millimeters. And then there's a ring, a split ring, that clamps around this and clamps it onto the shaft. That somebody's stolen it. So this has become a demonstration encoder, and that's why it's here. So encoders are not hard. That is the basics, and that is all you need to know about an incremental encoder. Alright? Alright? Got it? Please ask questions down below. Alright, down here. Write me comments. I'd love to hear them. Alright? Tell me if you like this. Tell me if you're indifferent to it. Alright? It's cool. Alright? And for the rest, have an awesome day further. Thanks for being here. Probably see you later for more stuff when I think something up. Something happens between these 2 years, you know. Alright. Take care, ladies and gentlemen. Bye.